see that out there in the field. All right, so I said we have a short amount of time. We're gonna squeeze this all in. We are gonna jump through fire extinguishers fairly quickly, but it's important to understand some aspects of fire extinguishers, okay? As far as the overview and purpose and factors impacting successful use, we'll jump into that. The location and the condition of use. If the portable fire extinguisher is not in good condition, we don't know if it's gonna work, okay? If it's dented, if it's rusted, that's important. We, out in the field, especially when we are out there inspecting amusement rides, they're all required to have portable fire extinguishers on every amusement ride. I stress all the time to take and look inside the hose, look inside the nozzle, because mud wasps and spiders like to build nests in there, okay? That changes the effectiveness of that portable fire extinguisher. Portable fire extinguishers are good for incipient stage fires, you know, when they're first beginning. Okay, we have to make sure, the other part, if people are gonna use a portable fire extinguisher, they have to be properly trained. Go look at some YouTube videos of fires and people trying to use a portable fire extinguisher if they're not trained. It's pretty wild, pretty scary. You mentioned OSHA 1910, that if there's portable fire extinguishers in the building, the staff should be trained in the use of the portable fire extinguisher. So every portable fire extinguisher needs to have a label on it. That label is going to give you the testing lab approval. Underwriters Laboratory is listed. The type of unit that it is, dry chemical fire extinguisher. The agent that's in there, okay, could be the classification. Some of it will tell you the agent that's in there. Sodium bicarbonate, you know, there's a lot of different types in there. Ammonium phosphate base, okay, tells you what's in there. Type of agent, the rating of it, 5 pound, this is a 5 pound unit. Up here, this one was a 3A 40 BC. That's just how much fire it can put out. Okay, well, we can talk about that in a little bit. The gross weight of the extinguisher, which is really important, okay? That's a 5 pound extinguisher. It does not necessarily mean it has 5 pounds of powder in it. The extinguisher itself, we take the tear weight of the bottle and then add the product until we get to that 5 pounds. The manufacturer, okay, gives you the manufacturer name, Badger Fire Protection. Okay, says it down here. And then the model number. There's your model number, VX 809242, 809242. The effectiveness rating, the bigger the number on the extinguisher, the more effective it is, the bigger fire it can put out. Class A's 1 to 40, Class B's 1 to 640. C, D, or K doesn't have a rating. Class A fire extinguishers, typical water can for those of you in the fire service. Chrome extinguisher, has water in it and air pressure. That's going to do wood, paper, rubber, plastics. Most of the time it's a 1.5 gallon extinguisher. Class B fires, cooking or grease, flammable combustible liquids and gases, as well as grease. Ratings from 1B to 640. Class B fire. Class C fire does electrical motors. You don't want to put water on an electrical fire. It will not feel good. Okay. Class D covers metals. Here's a list of different metals that it covers. Different dry powders used depending on the metals that we have. No specific rating on them. And then Class K is where we'll find in a cooking application. NFPA 96 requires, if you have a commercial cooking hood, it requires you by code to have or by the standard, to have a Class K extinguisher on top of having, in addition to having the hood system. Every extinguisher has to have pictograms now. Back in the early 2000s, I had bought out a fire extinguisher company while I was doing my plumbing and heating business. So I recharged, refilled, inspected portable fire extinguishers, installed NFPA 96 hoods. That's when, about the time that it became a requirement, 2001-ish, I'd say, that pictograms had to be there. And that was for Americans with disabilities, individuals who could not read English. That way they can look at the pictures. In this case, this is telling me this is A, B, C, and D. Or K, A, B, C, okay. It's telling me these pictograms, regardless if I pick up an extinguisher that has this, it's only good for Class B and Class C fires. This is only good for Class A. A and B, only good for Class K. Okay? They also had to, I had to buy all kinds of labels to make sure extinguishers had these. They had to have letter labeling systems because not everybody can read, not everybody can visualize what that pictogram means. So we had to have the A, B, C, D, and K this way. Has to be on that, color coded. Some people are colorblind, so then the symbols have different shapes to them. A water can or a water extinguisher has water in it. You pressurize it with air by a little snifter or Schrader valve. The air pressure puts pressure here. When you squeeze the handle, the air pressure forces the water up the tube and out the nozzle when you squeeze that handle. This is the same type of scenario, but it has a plunger that you actually pressurize. Stored pressure, your normal ABC type extinguisher or BC type extinguisher has your dry chemical in here up to a certain point and weight, and then you charge it with an inert gas like nitrogen. I used to carry nitrogen bottles around, and I had some in my shop. So that nitrogen would pressurize, and I'd pump it up until my gauge was in the proper green area, take the pressure off, lock everything down, and be good to go. Same scenario as the water can. Pressurizes it. When you squeeze the handle, the pressure forces the powder up and out the nozzle. This is the same scenario here, just a different style nozzle on it. Old school dry chems, don't see a lot of these anymore. Big CO2 cartridge. This plunger right here, you'd hit it. When you hit it, you puncture the CO2 cartridge, it would pressurize. It would force that agent out the tube, and when you squeeze this handle up here, typically had an indicator on the cap up here in the center. Little plastic cap and pop up red. These drove around in fire trucks all the time, bouncing and bouncing and bouncing. I used to have to take a crowbar or a large screwdriver and a mallet because they bounced so much they compacted the powder like concrete, literally. So you'd actually have to break that powder up during the inspection to make sure that that powder was loose and would come out. Should do that with every dry chemical extinguisher. Should beat on it, pound it, hit it with a mallet, even before you use it. I've taught my kids and my wife, pick it up, slam it against the wall. Things are on fire, you don't care. Slam it against the wall upside down, get the powder loosened up before you use it. I would say 60–70% of the extinguishers that I ever had to service that were discharged still had 20–50% of the powder in it, even though it wouldn't work anymore, because it was compacted down. Carbon dioxide used to cool your drinks down sometimes, make frosty beverages. That is a liquid until, and it's pressurized. It's actually in the boiling state. When it comes out, it's boiling, still in a very cold temperature, but it comes through as a gas. okay? This tube right here is to prevent any liquid buildup and prevent any discharge of electricity coming back at you. That's why you have the long cone on there. Wet chemical, or your class K, same as a water can, except it's already it's pre-charged. It has a wet chemical system that's in there. Same scenario as a water can. When you work on a portable fire extinguisher, you have to do testing, hydrostatic testing, on a specific basis, depending on the type of tank that you're working with. They're supposed to stamp it out as far as the test pressure that they did, stamp out the month, or the year that they did it, the month that they did it, and then you're supposed to sign it. The state of Maine does not have any licensing, so you don't have to put a license number there in the state of Maine. But if you take off you see here, there's a plastic ring. If you take this head off to do any service on a portable fire extinguisher, that ring is supposed to be put on. Okay, they're not there on a new extinguisher, but that ring is put on to indicate the fact that it's been taken apart and serviced. And there's actual dates on that as well to indicate when it was last done. So we have to ensure that extinguishers are rated for the application, make sure that it's large enough to be effective, make sure that it's still in its operating condition. Operational readiness. Is this extinguisher ready to go? It appears pretty ready. It's in a recessed cabinet with a hose valve there for a NFPA 13 standpipe. Okay. We want to do an inspection, make sure it's in its designated place. Make sure it's where it's supposed to be. Make sure that the tamper valves, a little tag on there, seal, is still in place. It hasn't been tampered with. Make sure there's no damage to it. Make sure there's no condition that would prevent it from operating. Make sure it's not obstructed, nothing in front of it. It has to be accessible at all times. Make sure the gauge has pressure on it. The dates are within its required hydro test dates. And then the inspection tag is in place. It has to be inspected on a monthly basis. The tag gets replaced during the annual inspection from the Portable Fire Extinguisher Inspection Company. Extinguisher placement, NFPA 1, 13.6. That is going to tell you your extinguisher placement. That section is a small excerpt out of NFPA 10. NFPA 10 is the standard for portable fire extinguishers. If you have that question on your test and it asks you, what does NFPA stand for? NFPA 10 stand for? Where are you going to go to find that information? Chapter 2, reference publications. Look up NFPA 10. Cross-reference it. It will tell you exactly what that standard is for and what edition you should be using. So hazard classification is super important. You don't want to put a Class K extinguisher out in the middle of a corridor. Okay, it's not appropriate for the commodities there. Travel distance to the nearest unit. You will probably find a question on the test regarding the travel distance to the nearest portable fire extinguisher. In general, that travel distance is going to be probably between 50 feet for a BC type extinguisher or 75 feet for an ABC. But there are other requirements or other things that may dictate differently depending on your occupancy and all that. That information is found in NFPA 1, 13.6. Super important to tag that NFPA 1, 13.6 section in your book. Now, when they say travel distance to a nearest portable fire extinguisher, and it says 75 feet, that doesn't mean that you have to have one every 75 feet. That means anywheres in the room within 75 feet, I have to be able to get to a portable fire extinguisher. So ultimately, I can have, depending on your layout, I can have an extinguisher 150 feet away from where I'm standing. Because I can travel this way 75, or this way 75, or that way 75. Make sense? So there's tables, size and placement for Class A hazards, size and placement for Class B hazards within table 13.6. So in short, we got through that very quickly. In short, fire extinguishers come in different ratings and sizes. Specific hazards may require specific extinguishers. NFPA 10 is the standard for portable fire extinguishers. You'll find that in chapter 2, reference publications. NFPA 1, 13.6 outlines the requirements for the placement, size, type, and where it's required. 13.6 is your go-to anything for portable fire extinguishers if you have questions on your test. And it's not a big section. If you want to go through and specifically find table 13.6.8211 and 13.6.8311, you may want to highlight those and tab them.
NFPA 1.
And NFPA 1, yep.
Why am I not finding it?
Maybe because, remember we talked earlier at the very beginning, there may be sections that are not correct. So let's do a little digging a little further and find the correct tables that correspond with that.
He bought the Amazon
Because,
book.
what's that?
He bought the Amazon book.
Yeah, he bought the Amazon book, there you go.
I
No,
don't even have a 13 point.
this is definitely a typo. I believe the 8 is supposed to be a 3.
Table
That would make sense.
13.6.3.2.1 and
Okay.
3.3.
I did say the next person that found, I said that way in the beginning, the next person that found one would get a challenge coin or found the right answer for that. So, there you go.
So what is the right answer? 13.6.3 and what?
2.1.1 and then 13.6.33.11. Page
On the slides.
Instead of an 8 here, it's a 3.
122, 123.
And in that same section, I already had you look at it, look for it one other time, very early on, was the table of where portable fire extinguishers are required. That's another one, but you all know, because we talked about it right in the very beginning, everything requires a portable fire extinguisher, every occupancy except for 1 and 2 family dwellings. There are a few small places, apartments, that only hazardous areas, but in general rule of thumb, any occupancy that you go in, except for a 1 and 2 family dwelling house, is gonna require a portable fire extinguisher. So look at that, we got through portable fire extinguishers very quickly. Less than 20 minutes. There's not a lot of stuff on the exam relative to portable fire extinguishers, other than probably NFPA 10 is the standard for it. Maybe some travel distance questions, maybe some size and placement questions on those tables. Other than that, I think that's all you'll have to concern yourself with. All right. So speeding right along, we're gonna finish up module 4 and jump into 5. So, site plan, we're talking about plans and drawings. Again, not on the exam, nothing that's in that's in there relative to this stuff that I'm aware of. This is just good knowledge for everyone to have. Okay, communications, when we're dealing with plan review. When we're dealing with a plan review, it's important to have good communication, good plans, good drawings, okay? The plans and drawings, they have to be clear, concise. I'm the reviewer. Josh is the reviewer. Somebody needs to paint a picture of what's happening. If you don't paint a picture of what's happening, if your clients hand you stuff and it doesn't paint a picture of what's happening, you need to ask the questions. Okay? They all have to be clear, understandable. You have to understand what's happening, and it has to have all the necessary information that you need to ensure that it's meeting the compliance of the codes and standards. They have to use standard terminology and symbols. They never do. Architects and engineers never use the same symbols. There's no standardized thing. A smoke detector could be a star, it could be a bird, it could be an X, it could be a circle with an S, it could be a circle with an SD, it could be a square. You never know what it is. If they don't have a legend, specifically ask them for a legend. Okay? Whatever your symbols are, I have no clue what they are. So please lay it out for me. Give me a legend. Give me a breakdown. Okay? Our drawings, we require them to be scaled drawings. Scaled meaning a 1/4 inch on the drawing equals a foot in real life. Or an 1/8 inch on the drawings equals a foot in real life. If I don't have that, I can't use tools to measure it. Old school, we used to have little counter wheels. We'd start at 0 and we'd scroll along. Or a triangle type scaling rule. It would have a 1/4 inch here per foot, an 1/8 inch per foot on the other end. Keep flipping, turn it around. It would have all the various scales on it. Still have those. We don't see a lot of paper drawings anymore. I still have the scale wheels. We don't use them because we do it electronically on programs like Bluebeam and other programs like that. So plan views. A plan view, when we're talking about a plan view, it's a bird's eye view. It's this. Okay? 60,000 foot overview of what it looks like, the entire site. Site plan, civil plans. This is showing me the buildings, existing building, it's all hard to read, but existing building, phase 1, all the parking, the streets, property lines or boundary lines, or, the kind of the end of the drawings. It may provide all these little lines here, water and sewer, gas, electric, all of that stuff. This is a site plan view or a plan view. May even give us our grading. Josh is really good because he did that kind of stuff with DOT. Okay? He understands grading. If I see, circles and circles and bigger circles, I know that that's kind of plateauing off. Sometimes they'll actually have dimensions that change of the grade. Here's a plan view, single dimensional overview of the project. Really hard to decipher what's happening here in this project. Lots of times we'll get, this is what we're doing. Okay, that's great. That's the end result. What's it look like before? This is okay if we're talking a brand new thing, because I know that's how you're going to construct it. But I like to know what it looked like before and what's being demolished. Especially in a renovation project, it's important for me to get a visual understanding of what's there and what you're proposing. Okay, but these drawings, you may have drawings, different drawings. Framing, electrical, plumbing, reflected ceiling, which shows me, you know, it shows me the grid work like this. Shows me that I'm gonna have, you know, ACT or suspended ceilings or hard pan sheetrock ceilings. It gives me all the dimensions. May have mechanicals. MEP, mechanical, electrical, plumbing. I asked for those. Please send along the MEPs, okay? Mechanical, electrical, plumbing. So that's generally what you're gonna have. You're gonna have your site plan, you're gonna have your MEPs, you're gonna have your framing plan, reflected ceiling plan, maybe a floor finish plan, and a lot of other details as we get going. Oftentimes, we have to ask for elevations or an elevation view. When I ask for an elevation of a bathroom, I want to know, looking from this place where I'm standing, what's the mounting heights of the mirrors, the soap dispensers, the paper towel dispensers, the hand dryers, hair dryers, sinks, all of that stuff, grab bars for the toilets. That's an elevation. I'm looking at an elevation view. It's gonna look just like this. It's gonna show me a picture of the wall with a door, with the lights, with the exit signs, the emergency lights, you know, all of those items. Outside elevations is gonna show me what the building's gonna look like from the outside. This is a very benign picture here, but here is an elevation view of the outside of this building. This being the roof, a pitched roof, this being the outer wall that you're looking at, and this being this is a roof or a covered entrance with a multitude of doors. This is Bob's Hotel and Convention Center. Really quick, without knowing any information.
It's a huge building.
It's gonna be a big building. What else does this tell us?
It's gonna be a lot of people.
There's gonna be a lot of occupants in that building. That's a lot of egress right there. And if that's the main entrance, that's only 50%. Okay, so there's other means of egress out of this space. Minimally 3, most likely. But as you can see here on the title block, Bob's Hotel and Convention gives you your address. It tells you that this is the elevations. This is sheet A6. The date, the job number. Can't see, I think that says file. And then the scale, 1 inch equals 32 feet. Okay, so 1 inch of this equals 32 feet. So it looks like this is pretty big. So cross sections and details. This is a cross section or a detail of a set of stairs. It's telling me 3/4 inch plywood riser. It's telling me, let's see, 2 inch or 8.5 inch stair. Okay, 1 inch tread material. Here's the handrail. Got a 2x8 kicker down here to keep things from being kicked in and move. 1/4 inch per foot scale. That's a detail. We ask for a lot of details on our drawings. Bathroom details, elevation details, you know, window details, door details, handrail details. Schedules. This is a schedule. This is a door schedule. I go back to this drawing. Door 1, door 2, door 3, door 4, all kinds of doors outside. Doors that are inside, they all have to be labeled and numbered. So door number 1, 2, 3, 4, 5, they're all different doors. It gives us the size of the opening. That's 10 feet by 7 feet. I don't think that's a regular swinging door. Okay, most likely that is like a garage door. 3 foot by 7 foot, that could be a regular door, 3 foot wide. It's got some glass in it. It's that 3 foot door, HM, hollow metal. finish, whatever the finish type is, we don't have that. Door frame type, we don't have that information. Gives you all the details, sheet A 9.1, detail number 2. That's how you read that. So I would flip to sheet A 9.1 and see detail 2 in order to be able to find that door. Door jamb, the sill, if there's a sill that's required. Fire rating, that's important for us. 1 hour fire rated door, 1 hour fire rated door. And then the hardware set. Hardware set is gonna tell us, so set number 7 might have a closer device. It might have a kick plate on the bottom like those doors there. It might have panic devices. It's gonna give us all of that. So I would look up somewheres or ask for the hardware schedule. And that hardware schedule is gonna tell me all the information for that door. Oop. So reading plans and drawings, you have to determine the symbols that are being used, determine the scale of the drawings, determine the conventions used to direct the reader to additional details or other portions of the plan. That's what this is. These are details. Those are the sheets, and this is the detail number. Okay? It says dimensions on plans and drawings are most reliable. I disagree. I don't trust that. I will scale to make sure that it's equivalent. Make sure that things aren't screwed up, because I've seen that before. But see these here, these are telling me to go looking other places, because that means something. That 3, that 9, that 4, that 2. Maybe it's a note, maybe it's a schedule. We don't know. But we have all these dimensions here, different dimensions we're working with. Dimensions should not be obtained by scaling drawings. I disagree again. Because I have to calibrate and scale. I have to make sure that things are working, because they don't always match up. We have issues, and we've been trying to train some of our newer, even older inspectors. And somebody mentioned earlier, I think somebody was talking to me the other day about my iPad. When I go out and do an inspection, I am gonna get the drawings and bring them with me. Because how can I verify that things are correct if I don't have the drawings with me? I have no idea what I'm looking at. I'm looking at the basics. Yep, there's an exit sign. Yep, there's a door opener, that doesn't tell you anything. The project was permitted this way. That's the way it should be constructed. And if it's not, somebody's sending me some new ones. Okay? And again, systematic. Be systematic. Start at the front. I like to start when I come up on a building, I like to kind of do a 360 or close to it, at least 3 sides. Get an idea, make sure that things are where they're supposed to be, not obstructed, Make sure signage is in the right place. Make sure it even has a number on it. Most places don't, they forget that. House numbering, building numbering, super important. I started a numbering program in one of my communities that I was the chief in. I had to, because I actually went on a medical call for a cardiac arrest and drove up and down the road multiple times. The wife had to leave her husband from doing CPR to come flag me down, because no numbers or no houses were numbered whatsoever. And they were all white houses, The descriptions just weren't working. In an emergency, it's important. It's in the code. It's in most local ordinances for buildings to actually have numbers that are visible from the street. Firefighters all over the place have always wanted to do that, or run a hose through the window. So emergency access for fire departments. It's a key consideration for plan review. Not my job as a plan reviewer. I don't know anything about your municipality, okay? I would love to, but I'm just not smart enough to be able to do all 35,000 square miles of the state of Maine. So who determines the required turning radius for site access? Not it, not me. You do. You're a fire chief. You do. You're a code official. Work with your fire chief. You do. The AHJ should. Okay? I don't know what kind of equipment you have. You know, do you have a 105-foot tower, or do you have a little, you know, F-150 mini pumper? I don't know. It's up to you guys to figure that out. When I came into a municipality, my first week trying to learn that municipality, I had my F-150, my personal truck, and as I pulled into this new development that somebody was halfway done building, nobody ever thought of it apparently, I scraped going up the hill, it was so steep. We couldn't even get a piece of apparatus in that development, and nobody had ever thought about it prior to me. It's crazy, but you are the AHJ. Know what your cramp angle is, okay? Know what the turning radius is. This comes with every new fire truck. Every manufacturer can provide you this. As the AHJ, you should be able to determine and set the boundaries for what you need for a turning radius. NFPA 1, 18.5. So, NFPA 1, Chapter 18 is fire department access. That is a very good chapter for you to tab as a reminder to go to Chapter 18 for fire department access stuff. This one in particular was Exhibit 18.5, but we'll go backwards and talk about building access. The fire department access road shall extend to within 50 feet of at least one exterior door that can be opened from the outside and provides access to the interior of the building. Keep in mind, we start at the basics, then we provide exceptions from there. Okay. 18.2322, fire department access road shall be provided such that any portion of the facility or portion of an exterior wall of the first story of the building is located not more than 150 feet from the fire department access roads as measured by an approved route around the exterior of the building. So access roads have to be provided so that any portion of the facility or portion of an exterior wall of the first floor, first story, is not more than 150 feet from fire department access roads. Why do you think that's there? Anybody that has apparatus, ever you worked on a fire truck? 150 feet.
Because that's how much LDH we have in the back of the truck.
Not LDH, because LDH is water supply. That's from a hydrant. Pre-connects. Yep, your Mattadales, pre-connects, whatever you want to call them. 150 feet was always the standard practice. We started getting a little smarter and, you know, using different hose and whatnot, and we're doing 200 foot, you know, pre-connects mostly now. But 150 feet, that's why that's there. I have to be able to, from my apparatus, I have to be able to get to the building with 150 foot pre-connect. Now, if the building's sprinkled, you can increase that to 450 feet. Added extra bonus. As a code official, as a fire official, that's a selling point. Hey, listen, I don't need to have access to all sides of the building within 150 feet. I'll allow you to go to 450 if you put a sprinkler in there. That allows them to do some pretty things on the outside. They may like that. Okay, but these two sections, you might see something like that on the test. Fire department access, building access. Emergency access. Fire department access roads shall have unobstructed widths of not less than 20 feet wide, 13.6 high. The surface has to be maintained to support the imposed loads of fire apparatus and provided with an all-weather driving surface. Okay? I have to be able to get the trucks there. I need 20 by 13.6 high in order to get the trucks there. Now, as the AHJ, again, your mini pumper versus my 105-foot tower, I might be able to make those roads smaller if I know that that's all I have. Keep in mind, as the AHJ, that I have mutual aid that might be coming in. I might need Mark's mutual aid to come in with his 105-foot tower. So I might still need to have that 20 by 13.6. And I might have to have a pretty damn good surface for that 62 or 65,000 pound piece of apparatus. Sounds like thunder.
Yeah, if anybody's windows up, they might wanna go take care of it.
Yeah, no kidding. Windows, sunroofs.
It's gonna get bad.
Yep, I think so. Alright. So what do we see here? 20 foot by 13 foot, 6. They've met the requirements, we're good. Right? Right, are they good? No. They're not good. Some design professionals do this, don't want to raise it because we have apparently it's pretty nasty in Auburn right now. Because aesthetically, they don't want to raise it because it changes the roof lines. Okay, so they don't want to raise it, they don't want to change it. So we have to make provisions, other ways to make sure and ensure that we can get our apparatus properly around or to the other side. So we'll get back to this here in a second. Other considerations, a turnaround must be provided if the fire lane is over 150 feet in length with a dead end. You have to have a turnaround, an approved turnaround. Either I can, with my cramp angle, can turn my apparatus around and come back out, or do a T-turn, a hammerhead. That's allowable too. The grade of the access roads going up in. Make sure that bridge that I'm crossing can support the weight of the apparatus.
And is this for any any structure or
Yes,
commercial buildings?
yep, any structure. It does not specify. There are allowances for 1 and 2 family dwellings, but, I mean, there are a lot of 1 and 2 family dwellings that you're not gonna get them to do a turnaround, nor are you gonna get them to do a hammerhead.
We actually added it to our local ordinance.
Did you? Yep. So by local ordinance, you can get there, you know, but as a general rule, I can tell you, if I'm gonna build a house up there, no way in hell am I gonna have to put a cul-de-sac or a T-turn, you know, unless I'm forced to by local ordinance. So, review things. Okay, obstruction, bridges, make sure it's marked properly. Okay, in terms of parking, we need to maintain that 20 feet. We also have to pay attention to things like the valet parking. Can I put an F-150 there, like I can put one there? If I do, I've lost my 20 feet. I've lost my access, right? We have to consider that with site plan review. It's a lot to take in, a lot to remember. Old Orchard, you have bollards like that, right in the middle of Palace Playland. Okay? In order to gain access there, of course you can squeeze on the sides, but in order to get the apparatus in, the bollards actually have to be removed. We need to maintain fire department access, but keep people out. So you utilize things like a key bollard, or just, sometimes the key is down in here, sometimes the key is in here. Sometimes it's used by a hydrant wrench, unscrew it. Sometimes they just lift up and slide out of the way. All kinds of different options, but regardless of what the option is, make sure that the emergency responders have access to it. See, there's a hydrant wrench. That's what unlocks that, enables it to be lifted out. Okay, chapter 18, fire department access. It is an important chapter. There are a few questions in there. We want to make sure that you remember that. Fire flow, should understand. We already talked kind of about fire flow with sprinklers and hydrants and testing. This is a test gauge here, okay? Not sure, I can't tell, but a pitot gauge, probably. There's different versions of testing. Fire hydrants, they provide water for manual suppression, automatic sprinklers, and standpipes. Hydrant distances are located within NFPA 1. Number and distribution of fire hydrants. There used to be this table. Now they've simplified it into this table. So if you want to know maximum fire hydrant flow capacity, how far from the building, okay? Maximum capacities are here, depending on the distance of the building. A question that you may have is, I have a building that is within a hydrant within 300 feet. I have to have a maximum capacity of 1,000 gallons per minute. Standard design rate for fire mains that support hydrants, 6 inches at 20 PSI. No one bouncing through this quick. This is just showing you a flow chart. Static standing pressure is 75. We start flowing, my residual is 60.5 while I'm flowing 1,000 gallons a minute. Here's our hydraulic information that we'll find on a sprinkler design. Okay, this is just telling you where this falls in this flow chart. Fire flow requirements for buildings. NFPA 118.4. That's your chart. I'll give this to you for a minute. I guess that all.
All right, fire flow requirements for buildings, you'll see it, it's all split up by building, like construction type and building size. And it's gonna require how much water is gonna be needed over a certain period of time. So a fire flow question, you're reviewing the plans for a new commercial structure. The building is 8,500 square feet. It's type 5000 or your common wood construction. The owner's installing a fire pond for water supply as the building is out of the water district. How big does the pond need to be? So you'll be utilizing this table in NFPA 118.4 to come up with that answer.
looking at table 18.4.5.
$300,000.
300,000 gallons. So you have 2,500 times, and then you got 2 times 60, so you're looking for 2 hours worth of water. And you're looking at 300,000 gallons of water to be able to sufficiently put that fire out. Does that make sense? Easy to follow?
Can you jump back for a second, just so we can see that? Alright, so the 85 is between 7701 and 9400. That's where you came up with 25.
Yeah.
So where did the, in the parentheses, the 2 times 60 come from?
So it's gonna require so many hours worth of water.
I understand that.
So the chart gives you 25
Yeah, I see that
per
here.
minute.
Well, where did your 60 come from? It almost looks like it's
60
constant.
minutes and an hour.
Yeah, so then you need it's fire flow ratio for 2 hours. So you take that, convert it, the hours to minutes, 120, and then 120 times the
Gotcha.
2,500.
Okay.
Right.
So, type 5 construction, and you have your your square footage of the building, fire flow, gallons per minute. So you need 2,500 gallons per minute. You need 2 hours for flow duration, so that's where your 60 is gonna come in. So 2,500 gallons for 120 minutes is gonna give you 300,000 gallons of water.
Oh, okay, I see it at the top there, it's showing it liters, well, liters per minute, but it's gonna be gallons per minute also.
Right.
APM. Gotcha. I follow it.
So fire flow requirements for buildings, required fire flow shall be produced by 75%. So this is some things that will allow you to reduce the required fire flow. When the building is protected throughout by an approved automatic sprinkler system, the resulting fire flow shall not be less than 1,000 gallons per minute. So if you have that building requires a certain amount of water to flow, they put a sprinkler system in the building, they can reduce that fire flow by 75%, as long as it does not drop below 1,000 gallons per minute. Does that make sense? Then required fire flow shall be reduced by 75% when the building is protected throughout by an approved automatic sprinkler system, which utilizes quick response sprinklers. The resulting fire flow shall not be reduced less than 600 gallons per minute. So if they opt to use quick response sprinklers instead, throughout the building, they can reduce that required flow rate even further. So that 300,000 gallons, you remove that, take 75% away, you're now down to 75,000 gallons with quick response sprinklers. If you just use the sprinkler option, you're down to 120,000.
So in the upper circumstance, let's say, calculation brought you below 1,000,
Yep.
stick with 1,000.
You're still stuck with 1,000.
So does this still, would this apply to, you have a sprinkler system in a residential structure?